So about 5 years ago, we bought Après, and at that point, we had new lead acid batteries fitted. The batteries are getting to the end of life, and we've been thinking about how do we replace them? Do we replace them like for like, or do we go to a lithium battery upgrade? So accordingly, we are going to go for a lithium battery. So we're going to make a series of videos about the install, but starting with this one where I'm going to go through the schematic that Après already has, and then the schematic that I'm going to build up to, and the equipment involved in that. And we're going to do unboxing of those pieces of equipment as well.
So now I'm going to talk about the schematics that we're going to use through this build. So this is the current schematic we have on Après. Let's start with the batteries. We have two lead acid 120 amp hour batteries which were fitted basically in February of 2020. The previous owner had added gauges here to them, in fact to all batteries. There's also a start battery here, and both of these batteries lead to a battery switch and are connected into the house panel like this. Currently the alternator and engine system is connected into this line as well. So this goes to the engine. When I bought the boat, it already had this triple bank shore power charger, which basically has inline fuses on each of the lines. But those are pretty much the only fuses that the boat had, apart from the breaker in the DC panel here, but nothing to protect the wires coming out of the batteries when I bought the boat. Since then, I've added this Renogy solar charger here and the solar panel here. At that point, I didn't put any fuses in this circuit. I probably should have done at that time, but I didn't. Last year, I fitted this Renogy 2000 watt inverter, and at that point, I did add a fuse to that system to protect that wire and circuit. The new schematic, so this is the schematic that we're going to move to. What we are going to do is move one of the lead acid batteries that was house 2 is going to move to be start 2, if you like. It's going to be connected into the start circuit, and the reason we're keeping it is for redundancy. This is the first time I've had lithium on the boat, and if I do have a failure in any of the circuit, I can switch over to the opposite side and basically use some of this lead acid battery in a short period of time to get me home. So what we've got is we've got the lithium battery added here, which is a Docan Power 300 amp hour battery, and will be assigned house 1. As the lines come out of here, we're going to have firstly a class T fuse. There is going to be the gauge in there, which was in before, but I am adding a 1 amp fuse in here as well. You might say, why is this on this on this side of the class T fuse and not on the other side? And that is really down to how many connections we've got. I'm trying to keep the connections to the battery to no more than 4 connections per any terminal, which is a guideline according to both the US Coast Guard and the ABYC. This connection will be a short connection to the fuse, and then from the fuse there will be the charging circuit will connect all the different ones. So we basically have 3 methods of charge. One method is the Renogy solar panel, which is what we've had previously, and another one will be a specific battery charger, a shore power battery charger, so AC to DC charger from EcoWorthy, and then this line here will be a 20 amp DC to DC charger from Renogy. And I'll talk a little bit more about the components in a bit. Then also from this point here, we'll have a shunt, which is an existing battery monitor that we have on each one of the batteries. So we'll keep that. And we'll use it in combination with the battery monitor that's actually inside the lithium battery. And I'll talk more about that later. But basically what it's going to show me is it's going to show me the outgoing and the incoming current, and we'll be able to determine what the charge level is and what the consumption level is independently. Then we're going to have this dual MRB fuse. So there's two connected at once. The Renogy 2000 watt inverter will get its 250 amp fuse, and then the second one, this line here, which goes to the battery selector, will get a 200 amp fuse. Now this connection here is on battery 2, which is the same it is today. The difference is most of the time today we ride with both selected, so it's connected to the both connection. In future, this will purely be 2. So the start circuit will be completely isolated from the house connection, unless something happens with the lithium, and then we can switch to 1, or if we have a really low point where we need to charge from one to the other directly, we can do. So for instance, if we can't start the engine because whatever happens, something happens over here, we can always connect across between the two. And also in winter, it'll allow the solar to charge all 3 batteries. There is an ignition circuit switch which will go out to the switch in the dash, and then there's a half charge switch on the Renogy. And what this allows you to do is switch from being a 20 amp DC to DC charger to a 10 amp. And what I might do is I might use a ESP32 to monitor the voltage, which I've got here, monitor the voltage, and then if the voltage is at a certain level, to switch this to drop down to half charge. So this is the circuit. Things to take into account: no more than 4 connections on any terminal, class T fuse added to the lithium bank, so there's a class T fuse there. Fuses added to all connections to positive terminals to protect the wires. Now these are sized according to the ABYC tables. The components we've got selected, I'm just going to walk through what I've selected. So first of all, I selected this Docan Power 12.8 volt 300 amp hour lithium battery pack. Now this pack uses grade A lithium cells from Eve. Docan bring these into the US and they ship them out from Houston, which was good for me. I got it within 2 to 5 days of when I placed the order. It was really quick, and the price is right. $410 for a 300 amp hour battery is really, really good. I hadn't heard of the company before, and what happened is one of my subscribers and a friend who also sails out in Milwaukee sometimes, but basically lives on the Hook in Florida. He has 2 of these 280 amp hour batteries, and he uses them all the time. So he was raving how good the product was, and I've had the product now since the end of December, and it's now March, and I've been running it in the basement doing various tests, and it's been really, really good. I think I get more than 300. I get about 330, I think, out of it, based on the fact that it doesn't go off 300. It doesn't go off 100% charged until about 30 hours in of running a Raspberry Pi at 1 amp. It's really good. There's a link at the bottom here, and it'll be in the description as well. The BMS that it has is a JBD BMS, so pretty much there's a bunch of apps that you can use with it, and later on I'll do a demonstration of the app that come with it, and also another app that that I also use with it. But it does have an LCD screen on here, and will tell you the capacity left and what is being pulled out of it or pushed into it, depending on whether you're charging or discharging at the time. So it's really good to see that you can see that you're 100% or wherever you are straight on the battery. Then this is a Renogy 20 amp DC to DC charger. So this will go between the start circuit and the lithium circuit and provide a buffer so we don't pull too much current from the alternator, because the alternator has no method of regulation apart from its internal regulator, which is not very smart. So if you just connect it directly, it will you'll burn out your alternator. You've got two real things that are issues with alternator running directly to a lithium battery. One is pulling too much current, causes it to heat up too much, and you can burn it out. Or two, if you're pulling a lot of current and then once the lithium battery is finished charging, it just shuts off, and that change from being really high current to really low current can break the diodes that are in the alternator. So you don't want to do that. You want to avoid that. So that's what I've bought. The reason I picked this one is, firstly, Renogy stuff. I've got some other Renogy stuff on the boat. I like it. It works great. I bought it used from a friend of mine who didn't need it for a project he was working on. So it only cost me $60. So that's really the reason I bought this one. This is a eco-worthy AC to DC charger. So this is a plug-in charger. My existing charger that was on the boat isn't capable of doing different technologies at the same time. So you can't do like one circuit lithium and one circuit or two circuits lead acid. You can only do them all the same. So this will be an extra one. Plus, this is much higher current at 20 amps than the other one is. So this will give me a good fast charge. Not overly fast. I mean, I could have gone to a 40, but the price and the time and how much current it pulls, bearing in mind that I like to run it air conditioning with shore power, and I only have 30 amps available, so I didn't want to jeopardize not pulling more than the breaker will allow me to. Cost wise, it was $79. So it's a good price as well, and it's got a good rating at 4.7 stars on Amazon. There's a link here to this product as well from Amazon, and then some other parts that I used as well. Firstly, the Class T fuse holder. This one's a Renogy as well. I found that this was the most cost effective, so the Renogy one was pretty cost effective, so that was good. And also, it was the right rating and everything for me. And like I said before, I like Renogy stuff, so that's fine. And then MRB fuse blocks. Basically, I bought some singles and I bought some doubles for a variety of different things. And then here I bought some inline fuses as well. So basically, odds and ends that you need for this job. And here's some links to those. And that's all the components. So I bought a lithium battery for the boat, and it's from Docan Technology, and it's a 300 amp hour 12 volt lithium iron phosphate battery. And what I'm going to do right now is I'm going to open it. I've been in contact with the manufacturer. I asked a few questions. The manufacturer's rep was very easy to work with. She gave me a lot of answers. She sent me some specifications for things like the BMS and stuff like that. So far so good. So she shipped this box to me. It's got it's pretty heavy, 66 pounds or thereabouts. Usually I do this unboxing on the top of a desk, but because this is a little big, I'm going to do it on the floor. So this is the box it came. It's heavy. It's pretty concise. It's pretty small for the package. I thought it was going to be bigger than this. So I'm going to open it. Slip the plastic off the top here, and a little bit there. I should just pull, finish it off there, and here. Okay. So inside the box is another box. So now I'm going to take the second layer off. The second box is pretty much just got the code on one side here. Don't slice too close, but because I don't know what it's like inside. But it's got some foam, as you can see when you open it. There's a foam top, and it's quite thick. It's got probably an inch of foam on top, and then some contact stopper covers for the contacts and screws for the screws for the terminals. So that's the screw pack here. So like this is the screw pack for the terminal here, and it's got foam all the way around it, and it's got heavy reinforcement on the corners, so it's pretty well protected. Now hopefully, yes it does, it has handles here, so there are a pair of handles here, and I should just be able to lift it out. So here you go, lifted it out. You can see in the box that it's fully surrounded by this sort of inch of foam all the way around, so it's well protected. Doesn't look damaged in any way. Still in the plastic bag. So you can see now it's plastic case, and it looks good. So this should be a big upgrade for Après, who's currently got two 120 amp hour lead acid batteries. So really I can only use about 120, and this is a 300, and I could probably use most of this. I'm going to show you some features the battery comes with, namely the LCD screen. The battery management system that is on this device has a LCD screen that you can look at. So what I'm going to do is I'm going to get a close-up of it with my iPhone here. It's a little screen, but it's big enough, right? It's probably an inch by 2 inches, and when you press the button here, it lights up and it does a quick check, and then it tells you the voltage. So you've got the battery voltage there, the current that is being pulled from it right now, and as you can see, there's nothing connected to the terminals, so there's no value set in there. And then the current temperature of the battery at 19.4 C in this case. Also tells you the current state of charge. This battery, when I received it, the state of charge was 34%. But that was in December of last year, and now we're in March of 2025, and I've recharged this a couple of times because I've been basically using it in the basement here to power a few different things to see how it works, and it's been working great. I'm really impressed with it. I think I'm getting more than the 300 amp hours that it tells me that the maximum is here. I'm probably getting about 320, 330 from my estimations, but it's been great. So this is the LCD screen. What we've got above here is a way to make it easy for you to get the app. So basically, if you scan the QR code on the left here, which it says first step, scan that, and you get the app downloaded, and then scan that to basically set up the device into the app. That basically puts the MAC address into the Bluetooth app. And we're going to go there right now. First, I'm going to navigate over to the app, which I have in Home Automation here. And if we open this app, you can see that the battery is linked and automatically goes into the battery here. So 68% state of charge. And right now it shows me the voltage is 13.28. Current is 0 because we're not pulling any current. It looks at the cells. So high voltage of one of the cells is 332, 3.32.
and low voltage is 3.32, so they're the same. Cycle index is how many cycles it has been through. 3 cycles is what I've got. And then temperatures in Fahrenheit and Celsius. And then it looks at the voltage, the single cell voltage as well. It's very straightforward. It's very basic. The device list is very basic. And the app is very basic, which is fine. It does everything you really need it to. It tells you if the device is balancing, if it's in a protection mode, and if the MOSFETs are working on or off. So that's the app that came with it. I have been using a different app, so I'm going to navigate to that, and it's here. So in my sailing, I have a sailing area, and that's where I put it. Overkill Solar, and this device has found it as well. You connect to it, it gives you all the information. So here you've got the cells, and the cells are to 3 decimal places, so it's a little bit more, gives you another decimal place than the other app. And you've got 68% and 13.28 volts, and it tells you that you've got 204.2 amps left of 300 amps, and the power is currently 0, so your usage is 0. Temperature sensor 67 degrees, and basically number of battery cycles and number of times over voltage and stuff like that, which you can reset. Also, in the next page here is some settings, and it reads from the VMS. And then actually with this app, you can change things. So if you wanted to adjust these values, you could adjust them and basically change the point at which your charge temperature change, goes into protection mode and things like that. I don't think you want to do that. I suggest you don't do that. But basically, this gives you the option to do that. If you had a specific, requirement that you needed to deal with, then you could do it here. So that's the app. All in all, this battery so far, I haven't really put it under much in the way of stress. But if I do put it under stress, it'll be on the boat. So in the next video, it'll be installation and also unboxing and a review of the 2 chargers, the DC to DC charger and the AC to DC charger that I'm going to use, and pros and cons of each of those devices.
Thanks for watching. Please like, subscribe and comment.